Hello students, welcome in my lecture series. Now in previous part we have seen the application of normal probability curve when the percentage are given. That means how to find the score limits of a given percentage in normal distribution. In this part we will consider the application of normal probability curve as the how to find the score limit which include the highest given percentage of the cases. So let us consider the example. Given a normal distribution with mean of 120 and standard deviation of 25, what limits will include the highest 15% of the distribution? Highest 15% of the distribution. Therefore, the highest 15% can be counted of right half of the normal probability curve. Now we draw the figure of normal probability, the normal probability curve, and if we draw the perpendicular from peak point on baseline x-axis, then it meets in a point M where the uh, measures of central tendencies are concentrated. That means here mean, and 50% area lies to the right side of the ordinate and 50% area lies in left of the ordinate. Now highest 15%, that means highest means at this side, and suppose this is the area, this is the area including 15% cases in a normal probability. We assume that the lower limit of this area as x. Here we have to find out the value of x or the score x. Now what are given? Mean is equal to 120, standard deviation is equal to 25, and we have to find the score limit of the highest 15% in the distribution. The distribution is normal. Now we assume that, or suppose x is the lower limit of x is the lower limit of the highest 15% cases. X is the lower limit of the highest 15% cases, and we have to find out the value of x. 15% cases lie above the score x, and we know that 15% cases lie on the right side of the mean as well as on the left side of the mean. The area between mean and the score x contains or include 35% cases. 35% cases are included in a limit mean and score x. We have to find out the value of the score x. That means we have to find out its sigma distance from x, its sigma distance from mean. Now use the normal curve table. Here between mean and x there are 35% cases lie. That means between mean and x there is, between mean and x there are 35% cases. To find the sigma score equivalent to x, raw score x, we use the curve table. From the normal curve table, it can be seen that 3508 cases out of 10,000, it is near about the 35%. From the normal curve table, 3,500 3,508 cases out of 10,000 population are at a sigma distance 1.04 sigma from mean. The score X is at a sigma distance 1.04 sigma from mean. Sigma score equivalent to raw score is 1.04. Sigma score equivalent to raw score X. Is equal to 1.04 sigma. See again, from normal curve table, there are 3,508 cases out of 10,000 population are at sigma distance 1.04 from mean. Or we can say that there are 35% cases between mean and 1.04 sigma. There are 35%, that means approximately 35% cases lie between mean and 1.04 sigma. Therefore, sigma score equivalent to raw score is equal to 1.04 sigma. And we know that how to find the z score. It is we use the formula x minus m upon standard deviation is equal to sigma score, that means 1.04 sigma. This implies that means if we simplify this, then we get x is equal to m plus 1.04 multiplied by standard deviation, and putting the values in formula we get 120 plus 1.04 multiplied by 25, and its value is 146. That means this score is 146 and it is at a distance 1.04 sigma from mean, to the right of side of the mean, because the we have to find out the score limit of highest 15% cases. Now one limit of highest 15% is x, that means 146, and other limit is the highest score in the distribution, that means limits of highest 15% cases are 146 and the highest score in a distribution. Now we solve the second example. Let us consider second example. In a normal distribution with a mean of 15.20 and standard deviation of 2.80, what limits will include the highest 12% of the distribution? Here we have to find out the score limits of highest 12% of the distribution. What are the given things? Mean m is equal to 15.20 and standard deviation or sigma is equal to 2.80, and we have to find the limits of highest 12%. Highest 12%. Suppose the lower limit of the highest 12% of cases in a normal distribution is x. We assume that x is the lower limit x is the lower limit of the highest 12%. Now see the figure. Always consider the figure. Now highest 12% lies on right side of the distribution. Suppose here the 3 sigma distance, that means this point is shows 3 sigma, and highest 12%, say this is the highest area, this is the area including highest 12% cases, and its lower limit is x. That means this point is x. Now this is the area including 12% area. That means the remaining area is 38%. It is 38%, or we can say that the area between mean and the score x include 38% cases. Now we have to find out x. So find out the sigma distance of a raw score x from mean by using the normal curve table. So from normal curve table, it can be seen that 38% or 1800 cases out of 10,000 is halfway between 1.17 sigma and 1.18 sigma. So 3,800 cases out of 10,000 cases or 10,000 population, 38% cases at halfway of 1.17 sigma and 1.18 sigma from mean. Therefore, we have to interpolate the 1.17 and 1.8. So we get the sigma distance of the raw score x, or sigma score of the raw score x as, therefore sigma score of the raw score x is equal to 1.17 plus 1.18 plus 1.17 upon 2, and which is equal to 1.175 sigma. That means the sigma score of x is 1.175 sigma. Therefore, we can say that x minus m upon sigma or standard deviation is equal to 1.175 sigma. And putting the values in this equation, because how to find this sigma score of given raw score, but we use the formula x minus m upon standard deviation. So x minus m upon standard deviation is equal to 1.175 sigma, and put the values, we get x is equal to m plus 1.175 multiplied by standard deviation, and therefore x is equal to mean is 15.20 plus 1.175 multiplied by the standard deviation 2.80, and which is equal to 18.49. 18.49. That means the value of this score is 18.49. So we can see lower limit of highest 12% is 18. Approximately we can consider it is at 80. Lower limit of highest 12% cases is 18, and the upper limit of this 12% highest 12% cases is the highest score in a distribution. In this way, in this part we find the score limits of the highest given percentage in a normal distribution. In next part, consider how to find the percentile from a percentile point by using normal distribution.